Welcome to the Beyond Seattle SRE Meetup. This is our September edition, back to school, and we've got I think a really great agenda. It's fun speakers today. So thanks everybody for being here. My name is Kit Merker, and I'm one of the organizers of this event, and very happy to welcome everyone here. We've been doing this since January, and we've adapted to making this a remote, online, virtual event. Used to be in person, and we've also expanded our charter outside of Seattle, so it's great to welcome people outside the Seattle area. We still have kind of our core in Seattle. You'll see from our T-Mobile and Microsoft speakers today, very Seattle-centric day today. I wanted to encourage everybody to subscribe to the YouTube channel where we publish these videos. If you go to the link here, which maybe Urza will post in the chat, but if you go to the Noble9 Noble9 YouTube channel, you'll find past recordings, and you may be watching this right now on that channel. So to future people, thank you for watching. But check it out, and you can see Tim John's there, right? He's up on the screen. So there you go, there's Tim, there's Inception, okay. Some really great content. Let's see, so today, the agenda, we've got Richard Harrington from T-Mobile, and he's gonna be talking about the human side of SRE. Very much looking forward to that. After that, we'll have our breakout networking, and I'll explain more when we get to it. The important thing to remember is that after the breakout, you want to come back to the main room. So we've had people kind of drop off before, but we'll want you to come back. We'll spend about 15 minutes doing the networking portion of our event, which is, by some counts, everyone's favorite part. And then we'll come back and we'll hear from Les Lincoln, who's with us, a Microsoft SRE team, and he'll be talking about his talk, which getting into some great stuff there. We've done actually an interview before on the Noble9 YouTube channel as well. So looking forward to seeing his talk there. And then the hiring manager rapid round, where hiring managers can share their job postings and explain why people should come work at their company. And then we'll do a Q&A session, and we'll say goodbye to everyone, and we'll make some announcements toward the end about upcoming events and things like that to come to. So that's our basic agenda today. Before we get started, I want to share with you the hiring managers. If there's any hiring managers in the audience right now, and you're thinking, wow, it'd be great to plug into this community and talk about what kinds of roles are available on your team or at your company. We used to try to make it focus on SRE roles, but really any technical job that you have that you want to share, we're happy to do it. You just have to do it in 60 seconds. And so if you want to participate in this, it's a lot of fun. I set a timer. Just send me a DM in the chat, and we'll put you into the game. And all we need from you is basically your contact information, and we'll put you onto the agenda. It's really a lot of fun. Reach out to me privately as the talks are going on, and we'll get you in there, okay? And without any further ado, I'd like to introduce Richard Harrington, who's going to give the first talk. Richard, would you like to take over the presentation?
I will. Let me see if I can successfully manage to get this to work. While I'm doing that, I will see if I can talk and type at the same time. So my name is Richard Harrington. I'm currently responsible for something called the Architecture Strategy Team at Digital at T-Mobile, which means roughly the customer-facing websites. I used to be responsible for operating those websites as well, so that's where a lot of these insights come from. So let me dig into it a bit. So a couple years ago, I always have stuff on my desk. I'm always fiddling with stuff. And I bought a whole bunch of those stress balls. And actually, I ended up buying 6 dozen of them because they kept on getting destroyed. And I began to think, there's something going on here. I need to figure this out. Just one side note, those ones on the right there, the kind of the flexible ones, those are actually kind of interesting. They're filled with this like talcum powder. And you would think they would make a big mess when they exploded, but they don't actually. There's some water in there, so they're relatively safe. The rest of the ones, they just get torn up. So this reminded me of something I heard a while ago. This guy is Dr. Meyer Friedman. He came up with the concept of the type A personality. And they came up with it because they noticed that the chairs in their waiting room, the arms were being torn off the chairs. And he was at a convention, talked to some other doctors and said, does this happen to you? And they said, no. And he said, well, I'm a cardiologist. I'm dealing with these people, these type A personalities. He came up with that name and realized that there was this link between this behavior. So I started thinking about this and looking around and trying to figure out what were the traits that led people to be successful in this environment. And I came up with this model. So working my way from the bottom to top, and that's roughly in order of importance. So knowledge, aptitude, attitude, and judgment. So the first one, knowledge, to succeed, you do need to know a lot of stuff. There's an amazing amount of trivia in this environment, operating systems, cloud stuff. But at the end of the day, a lot of this can be taught. I would actually rather hire someone with the potential to do well, which really comes out to aptitude. Now, I was told I had to have a quote from the SRE book. So here is my obligatory Google SRE book quote. SRE is what happens when you ask a software engineer to design an operations team. Part of the reason I put this up here was I was at a conference and I was talking to Ben Sloss and I said, hey, we have the hardest time finding people to fill these roles. How do you do it? And his response was, actually, it was pretty easy. And I realized later, of course, he works for Google. They wrote the book. They hire all these people with all these skills and say, hey, come work in this group and we'll teach you how to do it all. But the first thing in aptitude is simply the ability to learn. You have to do it continuously. Every time you automate something, the next day you get to automate something different, which means you get to learn that whole new thing again. There's all sorts of coding. You really need to think about systems. You have to be very detail oriented. The sorts of questions I ask in interviews, do you use scripts or real language, manual or automation? And if they give the wrong answers, I know they're not the right people for this particular environment. The next area is actually, I think, one of the most important ones. Running production is inherently stressful. There have been many times where I'm about to change something in production and I'll think about it and I'll pause and I'll think, should I hit this button? Let me check everything again. Pager duty is great fun. Escalation incidents, being on phone calls with the CEO of the company, all sorts of good fun. So people, you have to have the ability to handle stress and you always have to be kind of improving. And you have to have kind of this core persistence, the ability to kind of keep pushing, solve the problems, no matter how stressful it gets. But the hardest thing and the most important thing is judgment. There aren't that many people that can handle this. You have to be able to make these good decisions under pressure. Quite often you'll have to make decisions where you're making trade-offs. Should we cut off this parts of the system just to save other parts? You also need people who can figure out how to avoid the problems whenever possible and to recover quickly. So thinking about this reminded me of what actually became kind of my role model for the true SRE. Admittedly, he was in a different industry, but I'll go with him here. So hopefully people remember the TV show House. He was a doctor. Every single episode, some poor patient would come in with some obscure set of symptoms, and he would stump around for the entire episode thinking how to figure out what this was caused by this. So to use slightly different phrasing for these different traits, you need a lazy, stubborn know-it-all who's very decisive, who's going to push through and figure out what the solution to these problems are. And if you've seen the TV show, that was basically every single episode. So let's talk a little bit about kind of the trouble signs, or at least how you know if your environment isn't the way it should be. The first one is burnout is a huge problem in this space. And if you look at kind of the generic list of what the causes of burnout are, it's workload, it's lack of control, poor environment, a values mismatch. Here's another link to some Google research they've done on successful teams. So prevention is largely about psychological safety. You've got to provide an environment where people can actually make mistakes. You should be able to dedicate time so that they can have a chance to do the automation, which is the eliminate the toil. On-call rotation is not a fun thing. Blame-free environment is very important, and that's also something that's in the Google SRE book. And continuous improvement. You just have to keep on making things better. I think the other area that's important is it's really easy to get in what I'll call a hero culture. One of my jokes was give me a fire turnout coat and a big hat. I'm just running around putting out fires. That's the wrong way to do it. You want to work smarter, not harder. If it takes heroics to keep production running, you need to fix that. It is quite easy to get kind of addicted to the adrenaline rush of having to fix production. But keep in mind, the person that fixed it last time might not be available this next time. Improve the processes, improve the systems, always make it so you're not relying on those particular individuals. A large part of that is you just have to provide the time. It takes lots of time. Automation is a big thing. And whenever anything goes wrong, you got to do the whole root cause thing. What caused it? Did monitoring detect it? And what are we doing to prevent this in the future? I actually created a macro. Every time there was an outage of any sort, I just kind of printed it out and said, hey guys, what are the answers? How are we going to improve it? So just to give you guys a little bit of a head start, here's just kind of a quick list of some of the troubleshooting techniques that I learned over time. First rule, 1A, it's DNS. Some of the biggest failures I've had to deal with were caused by DNS. I remember being woken up at about 4:30 in the morning one morning as my phone was blowing up because every single alert and monitoring system that we had set up was screaming at me because DNS was down. It was good fun. My phone was almost useless for a while there as I was trying to turn off all those things. But that's only rule 1A. Rule 1B, it's probably some human messed things up. Talking about the DNS example, it turned out that somebody had misconfigured the DNS servers, caused lots of problems. Another time, we had an outage and something went wrong, and I was trying to debug it and figuring it out, and then it happened again like 20 minutes later, and I couldn't figure it out. Then a little while later, it happened again. It's like, all right, what's going on? So ran into the room where most of the people were, and I said, all right, everybody, take your hands off the keyboards. I want each one of you to tell me exactly what you're doing. And eventually it turned out that one of the team had copied and pasted a script and hadn't bothered to change everything. So he was literally deploying to production the wrong code. That was good fun. Rule 2, if everything's broken, if just black screens everywhere, it's probably the network. It might be the DNS, it could be a backhoe somewhere, but if you see that kind of broad failure stuff, yeah, it's probably the network. One of the cases I had, network went out, and guy came up to me and said, he made a mistake. He'd done the wrong thing. He misconfigured something. And I looked into it and said, you know what? I would have made that exact same mistake. So I said, look, this one's on me. When I wrote up the RCA, I said, a team member made a mistake. Here are the things that we're going to do to prevent that from happening in the future. But that was important to me to say, look, it's a system failure. It's a process failure. So rule number 3, if there are random errors in multiple areas, it's probably a resource constraint. And pay attention to the different types of resource constraints. The most obvious ones are always CPU and memory, but don't forget the other ones, network congestion, file handles, open connections, things like that. Those are the ones that will get you, and usually the behavior is some stuff works some of the time, other stuff doesn't work, just different parts of the system kind of randomly going up and down. Kind of look for that behavior. Number 4, if it's half the time or a third of the time or a quarter of the time, it's probably a clustered resource that has issues. It's probably something that's misconfigured or a resource constraint. And quite honestly, these are almost always human failures. Something went wrong in deployment or something wasn't completely automated. So you need to kind of figure out which resource that is, get it out of the rotation, and then fix it so that it doesn't happen again. Rule number 5, yeah, it's not DNS, right? It's DNS. Quite often it is. And one of the things I learned was that not only does DNS going down cause all sorts of problems, when it finally comes back up again, lots of systems don't start working automatically. You have to go back and restart a lot of systems. I remember in a later massive DNS failure, I was saying on the bridge, all right, guys, the DNS is back up. That means these systems over here, you guys have to go flush your DNS cache, restart your systems. Otherwise, stuff's not going to work. So quick summary, circling back to Dr. House. In one of the episodes, he described how it was that he solved these problems. And largely what it comes down to is you have to visualize the system. You have to kind of look at the system's symptoms, form hypotheses, and then test them. Keep doing that. Check to see if they match the actual symptoms or that you need to look into something else. One of the key things to remember is that your first guess is almost always wrong. And you will probably have to keep repeating this until you're done, until you've actually figured out what that is, what the root cause is. And if you look at the, it's called the hypothetico-deductive model, that basically describes that process. I think that's it. So, Kip?
Awesome. Thank you, Richard. Round of applause. There you go. Silent applause. There you go. Thanks so much. Okay, so it's back to me now. So I'll get back on the agenda here, and we're moving right along, which is great. So thanks everybody for participating. And if you liked the breakout, I will I'll just plug our coffee meetups we do every other week, Thursday mornings, or every other meetup, I should say, on Thursday mornings at 10 a.m. It's pure networking, no speakers. So if you want more of the networking fun, that's a great opportunity. So handing off now to Les Lincoln, who is gonna, I'm told, take us on a journey of SRE, planning, philosophy, and whatever the third P stands for. So here we go. Les, are you there?
Yes.
All right, I'm gonna stop sharing and you're gonna take over. And here we go.
All right. Hey, everybody. How are you today? So I want this particular part of the session to be a little bit more interactive. So what I'm going to do is kind of introduce this topic of the 3 Ps of SRE from my perspective. I'm going to tell you a little bit about myself, and then we're going to trade some war stories and solutions, because I think everybody has experienced some of these things, right? And the best way to kind of transfer that knowledge is really just to kind of talk about it, right? So what are the 3 Ps, right? The things that I'm talking about today are planning, philosophy, and perspective, right? And I generally like to start with planning first, even though that's not how industry actually lets us, work or step into SRE roles. What am I talking about when I'm talking about planning? So I've been fortunate to have a really solid look at least 2 clouds and maybe 3. When I look at Google's cloud, Google was really planned fairly well from the ground up, right? Because there was a engineering philosophy, there's a set of principles that kind of govern that, because originally they're focused on search really specifically, and the ads that went along with that search, and so everything kind of fell out of that particular thing. The second cloud I want to talk about is the one that I'm working on now, which is Microsoft, which is much more organically assembled cloud, right? So there's instead of generations of like hardware, there are generations of very dissimilar hardware that have kind of come into the fold. And so the planning for, hardware evolution and the software that maintains that hardware, et cetera, that's all very different than what you would have seen at, company A. So what does that really mean? From a day-to-day perspective, it means that when you approach SRE operations or SRE production at Microsoft, you have a really different mindset around this particular set of tooling or automation that I'm going to build today needs to work in this really diverse environment. What I enjoy about that is that environment is much more like the rest of the world. What I don't enjoy about that is that it means that there are really a lot more permutations and complications of things that I need to solve for, right? So that's aspect number one, planning. Now, I talked a little bit about philosophy. What I mean by engineering philosophy is, what are we trying to accomplish and how do we plan on accomplishing it, all right? Many times I think businesses kind of leap into the business end of a computational problem without actually thinking about the engineering philosophy. And that complicates some of the solutions, not necessarily at the beginning, but generally when companies starts to become really successful, all of a sudden you have to scale this stuff and you're like, hey, wait a minute, this actually won't scale the way that it is because I didn't think it through from the beginning, or I didn't spend that money at the beginning. That sounds a lot like planning, but it's kind of the pre-planning of how are we going to think about what this compute platform all up is supposed to do, and how do we think about solving computational or software problems together. And then the last P is perspective. And this one's really personal for me because I've been fortunate to, like I said, to work in a bunch of places. When I was working at Mindspring, my perspective of the internet was really from the ISP perspective, right? Which is like, oh, there's a bunch of connections that I'm responsible for. There's a bunch of network, which is probably down, as Richard was saying. And then there's a bunch of other aspects of connectivity that are concerning to me because that's what I'm supposed to be concerned with. When I was working at Google, we'd look at not so much the network aspect, because that was important, and certainly we had outages, but more data centers, because that's what my focus was, and looking at how entropic failures happened. What this machine, this hard drive failed, this machine, this PCI bus failed. How does all of that add up into a problem for a particular service, and how do we think about fixing that? And then lastly, now at Microsoft, I'm looking at kind of these process scale problems where it may be that something is operating correctly for the design philosophy of yesterday, but not necessarily correctly for the design philosophy of tomorrow or the business needs of tomorrow. So you got to redesign that process to some degree. Now, all of that, and I'm lucky to have had the experience of seeing all of those. So now I can kind of pick and choose the perspective that I use to solve particular problems, or in some cases, if I'm really lucky, I will get to empathize or sympathize with the client and kind of look at it from their perspective, or a business partner, or some other firm, and say, oh, so when I look at it from your perspective, now I can kind of see that the thing that I'm doing is really kind of tripping your processes up in a particular way. The reason I bring all of these P's to the table is that I think the way that we approach solving them is what gives both our processes and our automation resilience, right? When we think of something being brittle versus something being resilient, a lot of that has to do with, in my humble opinion, the way that you kind of go about your engineering philosophy, your planning, and your perspective, right? So admittedly, we don't always get the luxury of building something that is completely resilient, but in some cases that is it's our stated goal. Whether or not we actually get to execute on that goal is kind of a fine line with the business that I'll leave as an exercise for the reader. So I want to reference one last thing, which I heard Richard say, and I really appreciated, right? That was kind of the hypothetico-deductive model as applied to people that can versus people that have, right? I think that one of the tricky things in SRE in general, because of that planning philosophy and perspective, is that it's generally hard to slingshot somebody from zero to, being effective in this space without actually throwing them in the deep end and letting them fail, right? So, you really have to have the air cover to take risks and sometimes succeed and sometimes not succeed in order to learn the lessons that allow you to have that perspective and build your own engineering philosophy. So as a manager, I think that's one of my jobs, much like Richard said, right, is to say, hey, you know what, I would have made that same mistake, or actually that was pretty good because the mistake I would have made would have been bigger, right, or something along those lines, right? But just giving your folks not even the luxury, the necessity of experience on the line at scale, I think is really important. Okay, so I've said a bunch of stuff. I kind of want to throw that conversation open and see what you think and where you agree or disagree.
So I've worked at Microsoft a long time ago, haven't worked at Google, but I have noticed that different companies do really have different philosophies. I'll toss out a hypothesis. Google as an internet native knew from day one that they had to be resilient and have systems that would scale and be able to support the queries of the world. Whereas Microsoft has kind of backed into this, almost forced into the idea that they have to host their own cloud. Do you think that's part of the reason why they kind of end up in a different place?
I do think that that's part of the reason, but I think to be really blunt about it, I'd find my experience at Microsoft has been much more business focused, right? And one of the things that I find really interesting about this space is that a lot of these concepts that we think are new are actually not new. They're actually really old, right? And so one of the things, and Kit will start poking me about this in a minute, one of the things that I routinely talk about is this concept of ubiquitous computing, which came out of PARC in the 70s, right? And where effectively cloud computing is on the road to fog computing, on the road to mist computing, which is on the road to ubiquitous computing. And those types of distributed and philosophical engineering systems, people have really thought through. We just chose not to actually do that.
That's particularly funny because I work for T-Mobile. One of our descriptions is we say we're trying to move from being a telco to a techco. And one of the things kind of pushing on is this idea that we have hardware all across the country. We should be able to do some sort of ubiquitous kind of computing of some sort. Should be able to do stuff more closer to the edge.
Yeah, and I agree with you, right? I think that as we, as an engineering society, kind of move to whip the rest of the lumps out of the cloud, right? We'll see more pressure from consumers to actually do that, to utilize that compute that's at the edge, even if it's, you're a Microsoft customer, but I'm going to use T-Mobile's compute because it's actually ideally placed for this particular client, right?
Hey, Les. Oh, sorry. Go ahead, Tim.
Les, you mentioned that you like to hire for potential rather than specifically hiring for, you like to hire people who can versus hire people who have. And in my experience, that resonates tremendously. That is exactly like my philosophy as well. I have a hard time sometimes, though, getting people who can, like, far enough down the interview loop to recognize that they can without having some of the like credentials or checkboxes on their resumes or whatever. And I'm wondering if you have any advice on how to sort of source or discover talented people who can, without getting too terribly distracted by a lot of people who have or claim they have, which at the resume stage is the same. Have and claim they have is the same thing, but can is really hard to get to show up. The potential is really hard to get to show up at the like super early stage. I'm wondering if you have any tips on how to, where do I meet those people?
You're here. This is where you meet them, right? I think, so thanks for that question. It's a really great question because one of the cheat sheets for that for me has been finding and trusting other people who have, but who also have that, oh, I remember when I was a wee lad and, I wanted to do X, and somebody gave me a shot, right? And so I think it's really important that your loop look to filter in, right, instead of filtering out. And this is a discussion that I've had a couple of different places now, right? It's one of the things that I think Microsoft says they value about me, but it's very disruptive, so I'm not always sure, right? Which is that I really encourage our engineering loops to filter people in, right? If they don't have some outstanding characteristics that says that this is a no-go, then we should probably go with that person and see, what they can actually do, right? But that requires, like I said, kind of a trusted group of people who have kind of been there and can see that potential, because I can't necessarily do that all by myself, as you were saying, right? Once you start to filter people in and other people start to look around and say, hey, why are there people here who have not necessarily done this before and are questioning, kind of our basic tenets, right? They start to get uncomfortable, but they're supposed to be uncomfortable, right? If we're not uncomfortable, we're not growing. And if we're not growing, then we're probably falling behind.
Hey, what I was going to ask, Les, coming back to your whole fog and mist and that kind of thing, reliability at the edge, like when you think about like the cloud and trying to drive reliability and how you measure reliability in the cloud, it's one thing. But when we're talking about doing things in this very messy, sort of in the field, right, outside of our control, outside of our network, we don't know the devices, we don't know the consistency, we don't know if they've been owned. How do you create a reliability practice around distributed computing that includes both, the cloud and the edge and somebody else's computer?
That is also a really great question. My experience has allowed me to cheat a little bit there. At one point, I was working at a company called SecureWorks, which is basically a security as a service type of place where you do intrusion detection, intrusion prevention, and basically secure other people's networks. What was really interesting about that was figuring out how to know what traffic patterns look like for someone else's network, whether that's a hospital or the army or whatever, right? And figure out how to differentiate between what looks like normal activity and what might be something else, right? So you don't necessarily have to have the full cooperation of whoever's network it is that you're traversing, but you do have to have some kind of a familiarity with what that network may have looked like yesterday or last week or something along those lines, right? And just as Richard was saying earlier, right, if we are starting to distribute compute to other people's networks, then how do I get a container over there that I know is secure, even though I don't know that, and pardon me, Richard, for implying that your network may not be secure. I don't know the state of it, right? But I want to put work over there, so I need to make sure that that work is contained and appropriate to the level of security that I can assess for that network. That's all really hard to do, but it's also something that as we push for more ubiquity, we need to kind of formulate into our engineering philosophy going forward, because there are already companies that are, they make it their job to move workloads from Azure to Amazon to Google and back again. I hate to tell them, but that's probably an industry that's not long for this world, right? We really need to get to the point where these things can move relatively independently.
So I assume every network is insecure.
Which is a great assumption. I just didn't want to, you know, there's only, yeah, let's not point the finger at each other, right?
Thanks, Les.
Yeah, absolutely. I want to, if there aren't any other questions or comments, I want to kind of close out with a couple of anecdotes. So one of the things that has really kind of gotten me to this particular place is I grew up with Star Trek and Doctor Who and Real Genius and a bunch of those movies that kind of seem to be like right around the corner, but were actually really hard to achieve some of those things, right? But they gave me a real respect for people that do work in those spaces, especially places like NASA or the Nuclear Regulatory Commission, or things where, you know, failure has consequence, right? So when we think about some of the problems that we face on a day-to-day basis that seem weird or hard to solve, I just want to give you a couple of examples of things that I've stumbled across that, you know, you just wouldn't normally consider being difficult, right? So I'm going to read a couple of these. Just bear with me for a second here. So this one's called backup power over voltage. Oh, hold on, my guys are barking.
Did somebody have that on their Meetup bingo? The barking dogs from the presenter? It's usually
Amazon delivering something.
Okay, so this one's called backup power over voltage. This is the setup is that it's an F-16 flight control system. Each flight control processor used diodes to combine sources of power. That's tenet one. Each flight control processor protected itself by disconnecting if its power supply showed any overvoltage, right? So this all sounds pretty logical so far. The third one, the overvoltage detection and the disconnect were after the diode that combined the power inputs. So what that means is by virtue of the placement for this particular control system behind the diode input, they kind of tied all the things together in a way that they didn't expect. So when the backup source of power had a mechanical failure where it stuck open, this produced an overvoltage that went to all the flight control processors, and therefore they all shut down, right? And so there were no flight control processors remained running on these F-16s, right? And this only happened in like this kind of weird situation where the Ram air turbine that runs the Ram jet on the F-16, if the valve got stuck open, then all of the flight control processors will go down, even though there were 4 of them, right? So it seems like really good design up front, and then due to kind of not even a mistake, but kind of a mischaracterization of the circuit design, right? You have this really serious error where all of a sudden there's no compute on this plane, right? Those are the kinds of things that I think really don't show up as, what's the word I'm looking for? They don't show up as kind of main failures. They almost always seem to be corner cases, unless you run into the law of large numbers, right? So as folks like yourselves start to groom out some of the garden variety errors, these things start to crop up, and you're like, they're real head scratchers, because you're like, how did this even come to be, right? You know, set of criteria that kind of led us down into this particular rabbit hole, right? A great one from Google time was that there was a period of time where I/O nodes, the I/O handles on certain boxes would fill up because if I recall correctly, these were diskfuls. So, probably 20 terabytes or 30 terabytes of disk with a bunch of open files on them. So all of the handles would go away. And then the device would start acting erratically. And you would think that it was a hard drive error, but no, actually, you're just out of file handles, right? So to Richard's point, right? Some of these things seem really intuitive, but they're probably not, right? So I just want to leave you with that thought for when you're thinking about how resilient something actually is. What's the orthogonal factor that isn't actually orthogonal?
So related to that, back in I think the 60s, IBM did a study and they found that software bugs ended up in kind of three categories. The first category would get found pretty much immediately. Second category, days, weeks. And the third category, months, years. And every time you fixed a bug, you introduced equal numbers of bugs in those other categories. So what that meant was over time, you fixed all the ones that you found quickly, but you gradually created more and more of the annual ones. It's an interesting problem. It's very hard to catch those, especially one of the big problems I have with creating automation is, it takes 100 iterations at least to test out some automation to make sure it's working properly. Well, if you're testing it out, trying to, make it work in your cloud, how do you test it against production 100 times? You can't really.
Yeah, you have to test in production, which no one wants to do.
I think you raised an interesting question, which is what's the difference between a test and a monitor?
I'd say a monitor is just looking at symptoms, whereas a test is trying to push the system through various states.
I would agree with that, right? I think monitors are more for average production states, whereas tests are things that are touchy, right? And you want to see how touchy they actually are.
I think with the combination of some chaos engineering, probes, synthetics, plus monitors, right, you can kind of start to get to this point where the distinction of there's a testing phase and there's a production phase could start to blend together. It's kind of what I was getting at.
Okay.
Do people do canary testing?
Absolutely. I'm a huge fan of canary testing, as long as you have the infrastructure to support it. But even more so, Jolene, I would say, if you can, I like commissioning testing even better than canary testing, right? Where
what kind of testing? Sorry.
When you commission something,
okay,
and you run it to at least 100%, if not 120%, or something like that, to see if you can flush out some of those corner cases that would not occur at normal production utilization. You don't always get the luxury of doing that, but if you can, I've found it to be valuable.
Okay.
So I want to, Les, is there anything else you wanted to cover? We can come back and do some more Q&A in a little bit, but I just want to kind of keep things moving forward.
Yep.
You good? Thank you for an amazing interactive discussion, and we'll have some more Q&A at the end with Richard and Les. Thank you, Les. A little golf clap here. Okay. We can do some Q&A as we always do and open the floor up and let's just have a chat. Come on, Richard, what do you got?
We could do war stories.
I'm open to it. Let's hear a war story. What do you got?
So I was debugging some stuff in an offline stack one time, and all of a sudden it started restarting. And I thought, what the world's going on here? And then it turned out that production was restarting also. And it turned out a script that I had written had a very fatal bug, and it was trying to deploy the newest, actually hotfix pre-test version of some code to every server in our cloud simultaneously. So it was great fun. Production restarted in the middle of the day, and it came back up, and the new hotfix was installed. And I looked around and I said, well, I guess we're going to test in production now because the hotfix is live. And it was a very stupid bug. I still don't know how it slipped through, but anyways, that was a fun day.
So I'm going to tack onto the war story a question. So we are getting ready to sort of revamp our postmortem process. It's been fairly passive, and we're looking at starting the live postmortem. So I'm kind of curious how you guys have been handling kind of you're like, because there's always some shame involved, right? But so how is your organization kind of handling, you know, the mistakes and learnings and that process? This is for Richard or Les or whoever.
What we do, and I actually still find this kind of mind-boggling, is there is a 7:30 a.m. meeting every other Tuesday that has almost all of the vice presidents on it. And we walk through RCAs on any of the events that have happened in the last couple of weeks and talk about what happened and what to fix it. And basically, from very high level, they've made it very clear that it is everybody's goal to fix the issues, find the root cause, fix it.
I'd say my experiences at Microsoft and at Google have been very different, right? Where at Microsoft, there are a lot of coalitions and fiefdoms. We run in a very federated manner, right? So a lot of the postmortems are what part of the larger failure did my team do, right? I was really kind of concerned with what this part of the system or process did and whether or not we did it correctly. That I think goes back to the conversation that we were having earlier about how did you get to the cloud that you have, right? Do you understand that this is one large system, or is it a conglomeration of smaller systems, right? Google did this in a very different way where they looked at kind of the holistic approach and said, oh, well, you know, this whole process is busted. So we may want to go back and re-engineer the whole process. That also is fraught with peril though, right? Because if you have a process that touches like 18 departments, then it will take you a long time to actually refactor that entire process. And by the time you're done with it, that whole code base might actually be obsolete, right? So I think you really kind of have to fine tune the level of RCA that you're going to do to the problem that you have. And some of that, again, goes to perspective, right? Do you have the engineers on hand to look at this and say, you know, yes, this was a problem and it did affect production, but it's you know, maybe a Sev 2 or is it a Sev 0, right? So. Does that answer your question?
Oh, sorry.
Yep, go ahead. Go ahead, Colin.
Oh, I was going to come back to Richard actually. So when you guys have this meeting every other week and everyone kind of gets in the room, it's all about root causes. Is there like a theme of why maybe things didn't get caught before they got to production? It sounds like maybe that's what you guys are looking at mostly is production escaped bugs. Is there, because I would imagine T-Mobile has a million solutions to kind of look for all that stuff and processes in place that have been around for a long time, but.
Well, so I've worked at a couple different telcos now, and my metaphor for them is we're just big rusty aircraft carriers. They're just groups and systems and stuff and things in the basement, and it's pretty crazy. It's a very hard problem in a lot of ways. But for this particular approach, roughly what it comes down to is usually there's some discussion about the recent failures. some discussion about what are the patterns, and a fair amount of discussion about what do we change to make sure it doesn't happen again. There's a kind of a scoring system that is based on how quickly did we detect and diagnose the issue, how quickly did we get the right people engaged, how quickly did it fix, how quickly did it take to get everything back up and running again. So the long-term goal is to reduce all those.
2 cents on that is one of the hardest things to instill is like the blame-free culture is like that has to come from the top, and it has to be like rock solid, because if people are afraid to own mistakes, then no one's going to want to do it, right? And that's got to start at the top. Like, you know, people at the bottom of the pyramid can't make that culture happen.
Definitely, yeah.
As the tiny little company representative here too, that's even a problem at tiny little, super flat tiny little companies. If literally the CEO isn't on board with building a blame-free culture, you're going to have a hard time doing blame-free postmortem. Mm-hmm. And I have been extraordinarily lucky in that regard, but I have witnessed some organizations where even with 6 people and no titles, the fingers come out and you don't learn from your mistakes and you don't put anything into effect.
I think we're about done. So it was so great to see everybody. And thank you, Richard. Thank you, Les. It was fantastic and quite an honor to have you. We'll have the video out soon. Looking forward to giving away a lot of mugs next month and seeing everybody at the coffee meetup. So please tell your friends, all right?
Thank you very much.
And let's all give Urza a quick thank you for handling all the logistics today with a computer that was not working. Thank you, Urza.
Right. Yay, Urza.
All right.
All right.
Okay,
Bye,
take
all.
care. Bye-bye.
Thanks.
See you next time.
Bye.
Bye.